This is the first question, okay? Now, if you went properly through and did the whole Gaussian elimination thing and then substituted correctly to get the identity matrix, then your rows ought to be very similar or identical to what I've got. Okay, I'll show you why. Here's where you started, okay? Now, you can see this line here. That's where I've first gotten row echelon form. Okay? So you can see the zeros are here in the corner. The quickest way to do that is, just like I did in the previous example, try and get zeros in the front. And that means you've got two variables, two constants, two pronumerals left, right? And then do what you need to this one to make it a 0 as well. And then bam, you're there. Okay? So in this case, what did I do? I think from row 2, I subtracted, what did I subtract? I needed to turn a 2 into a 0.
2R1.
So I use this guy, right? 2 lots of R1, right? Row 3 is even easier to turn this into a 0. All I have to do is add row 1. Okay? From here to here, if I really want to get it in row echelon form like so, without swapping rows, even though you can do that, that -3 and that 4, you've got to multiply by both, right? So it looks like I multiplied this one by 4 and this one by 3. Right? And then once you've got these two, you can add them together, and that gives you row echelon form. Okay? From there, all you need to do is a bit of dividing. Divide by 8. Subtract. Divide by 12, -12. And then I just subtract all of the original rows, and there's my answer. If I had given you a system, you know, A would be -3, B would be 2, and C would be 3. Okay, here's my question. Multiplying by 0. We looked at 0 and division by 0 and why that was a problem last time. But in matrices, even multiplication by 0 is a problem. Okay? Has anyone worked out why? Can you take it? It's really easy to see if you just have a look at this final endpoint. Okay? Now we're done. We're finished. We've got our solutions for this. Okay? But just consider what would happen if I multiplied a row, any row, by 0. Okay, watch. If I take, say, the last row, let's multiply that by 0. Your first two rows are unchanged. And your last row, what would it become?
All zeros.
All zeros. 0, 0, 0, 0. You're like, no problem, right? Like, if I wrote that as an equation, it would mean 0 lots of A and 0 lots of B and 0 lots of C, that equals 0. Isn't that true?
Yeah.
It is true. It is true. So there's no problem with this line, right? It's not saying anything false. Where is the problem?
You lose the value of C.
Aha! Well, now here's the interesting. I kind of, it seems natural to say I've lost C, but what you've really done is you've gained every C. C can be anything. There are no more constraints on C. Right? You can put C equals 5 or 2 million or -1 or anything you like in there, any real value, and it'll work. So where's the problem? Where's the lie? It's there. You see 1, 2, 3, 4, 5, 6, 7 systems. They're all the same. The solutions for this system are the same as the solutions for this one, and all the rest. But this system is not the same. It's got extra solutions, right? So non-zero, trivial as it might seem, actually is really important.